It's Beacon. I'm back again. Recorded a whole video yesterday. Sat here for 20 minutes reading this Janus Pro paper, and my audio wasn't working. You know the crazy part is? I did an audio test first, and I somehow broke something in between my audio test and recording. So we're going to do it again. Maybe I'm smarter now. Maybe since I read it once, I can understand it better this time. I'm looking. I see my audio coming through, so hopefully at least you can hear it this time. So let's get into this. If you guys didn't know, Deepseek, they launched the actual Deepseek model. Everyone was like, oh my God, this is amazing. It's crazy. And then they said, don't worry, we have more in the chamber. We've got a multimodal model that can handle image generation and understanding. And we've improved the ways we can have one model do understanding and generation by addressing some previous downsides. So we're going to read this, see what we can understand. Get into it. Janus Pro, unified multimodal understanding and generation with data and model scaling. We got Zhaokang Zhen, Zhiyu Wu, Zhao Chao Lu, Xinzhang Pan, Wen Lu, Zenda Z, Zinkang Yu, Chong Ra. I know I pronounced all those wrong. I'm trying, people. All right, let's get into it. In this work, we introduce Janus Pro, an advanced version of the previous work, Janus. Specifically, Janus Pro incorporates an optimized model training strategy, expanded training data, and scaling to a larger model size. With these improvements, Janus Pro achieves significant advancements in both multimodal understanding and text-to-image instruction following capabilities, while also enhancing the stability of text-to-image generation. We hope with this work we can inspire further exploration in the field. Code and models publicly available. We love that. This is not what I read yesterday, okay? I read yesterday the original paper around Janus, not Janus Pro, I believe. I might be wrong. Let me just double check, okay? We're going to search Janus. We'll search Deepseek. We'll hit it with the Arvix. Here it is. This is the... Oh, God. Come on, people. Come on, people. You can see it's already purple. So here's the actual paper. This was the original one from, I believe, October 2024, similar group of people, which is decoupling visual encoding for unified multimodal understanding. Now, they've taken that paper and they've improved on it, and this time they've got unified multimodal understanding and generation with data and model scaling. So this is Pro, this is the OG, or this is the OG. Let's read the OG, okay? Because how are we going to understand the Pro if we don't know the OG first? So, new paper. Okay, so in this paper, we introduced Janus, an autoregressive framework that unifies multimodal understanding and generation. Prior research often relies on a single visual encoder for both tasks, such as Chameleon. Chameleon using a single visual encoder? How silly. You need multiple encoders. Now, however, due to the differing levels of information granularity required by multimodal understanding and generation, so being able to generate a new image, you know, your Dallys and Midjourneys and whatnot, versus being able to tell what an image actually has inside of it, how do I describe an image, those require different levels of information granularity. We can't use one encoder for that. So this can lead to suboptimal performance, particularly in multimodal understanding. To address this issue, we decouple visual encoding into separate pathways while still leveraging a single unified transformer architecture for processing, the T in GPT, that big old transformers, okay? They're not just like, I don't know, Transformers, were they good guys or villains? I never watched Transformers, so I don't know if they're good or bad guys. The decoupling not only alleviates the conflict between the visual encoding roles in understanding and generation, but also enhances the framework's flexibility. For instance, both the multimodal understanding and generation components can independently select their most suitable encoding methods. Experiments shows that Janus surpasses previous unified model and matches or exceeds the performance of task-specific models. The simplicity, high flexibility, and effectiveness of Janus make it a strong candidate for the next generation unified multimodal models. Okay, lovely. Good. Once again, Deepseek coming out with some innovation. Okay, in recent years, multimodal large models have made significant advancements in both understanding and generation domains. In the field of multimodal understanding, researchers follow the design of LAVA by using a visual encoder as a bridge to enable large language models to understand images. So before, we use LAVA, visual encoder as a bridge that enables LLMs to understand images. In the field of visual generation, diffusion-based approaches have seen notable success. More recently, some works have explored autoregressive models for vision generation, achieving performance comparable to diffusion models. To build more powerful and generalist multimodal models, researchers have sought to combine multimodal understanding and generation tasks. For instance, some studies have attempted to connect multimodal understanding models with pre-trained diffusion models. For example, EMU uses the output of the LLM as a condition for a pre-trained diffusion model and then relies on the diffusion model to generate images. However, strictly speaking, this approach cannot be considered a truly unified model because the visual generation functionality is handled by an external diffusion model. And while the multimodal LLM itself lacks the capability to directly generate images. Okay, remember, there's always other animals here. We got chameleons, we got emus. We're on Janus. Janus isn't even an animal. So before, they were using two different models. That's not as cool. We've got a unified model using one autoregressive transformer in the middle. Although there's different encoding for generating images versus understanding images. So one approach employs a single transformer to unify both multimodal understanding and generation tasks, which improves instructions following for visual generation. It unlocks potential emergent abilities and reduces model redundancy. Such methods typically use a single vision encoder to process inputs for both tasks. However, the representations required by multimodal understanding and generation tasks differ quite a lot. They're significantly different. In multimodal understanding tasks, the purpose of the vision encoder is to extract high-level semantic information. So we want to actually know what this thing looks like. We need high-level semantic information. Object categories are visual attributes within the image. How do all these little pixels actually relate to each other? How do we actually know that it's a wine glass sitting on a table inside of a well-lit room? You can't look at an individual pixel and know that. You got to kind of start grasping the whole thing. Now, the output of understanding task not only involves extracting information from images, but it also involves complex semantic reasoning. Therefore, the granularity of a vision encoder's representation tends to mainly focus on high-dimensional semantic representation. Now, by contrast, when we're trying to generate an image, the main focus is on generating local details and maintaining global consistency in the image. The representation in this context necessitates a low-dimensional encoding that is capable of fine-grained spatial structure and textural detail expression. Now, unifying the representations of these two tasks within the same model leads to conflicts and trade-offs. These are opposites. Understanding what is inside of an image versus creating an image, different problems here. Consequently, existing unified models for multimodal understanding and generation often compromise on multimodal understanding performance, falling markedly short of state-of-the-art multimodal understanding models. Okay, so if you actually want something that can tell what's inside of an image and generate an image, you're going to be kind of dumb at telling what actually is inside the image. You might be okay at generating images, but you're going to be dumb at being able to say, hey, this image has this. It's okay. We got Deepseek. We got the Chinese. They're going to solve the problem. We got Janus, a unified multimodal framework that decouples visual encoding for multimodal understanding and generation. They decouple the visual encoding. Okay, specifically, we introduced two independent visual encoder pathways, one for multimodal understanding, one for multimodal generation, unified by the same transformer architecture, the T in GPT. The proposed method offers two main benefits. Janus alleviates the conflict stemming from the different granular between multimodal understanding and generation and eliminates the need to make trade-offs between the two tasks when selecting visual encoders. Janus is also flexible and extensible. After decoupling, both the understanding and generation tasks can adopt state-of-the-art encoding techniques. Now that we've split these out, if there happens to be some innovations in the visual understanding field, we can use a new update, a new cool new encoder over there because they're separate. Moreover, it is possible for Janus to accommodate additional input types for the future, such as point clouds, EEG signals, that's brainwaves, and audio data, where independent encoders can extract features and then use a unified transformer to process them. Okay, this splitting of the different pathways of encodings allows us to be able to, in the future, pull in different input sources and eventually produce different output sources, it sounds like. To the best of our knowledge, we're the first to highlight the importance of decoupling visual encoding within the unified multimodal understanding and generation framework. Our experimental results show that Janus surpasses existing unified models with comparable parameter sizes on both multimodal understanding and generation benchmarks, achieving state-of-the-art results. Notably, Janus even outperforms some specific task models which have significantly more parameters. Specifically, on multimodal understanding benchmarks, MMBench, SeedBench, and POPE, Janus 1.3 billion achieves scores of 69.9, 63.7, and 87 on the dot, respectively, outperforming Llama v 1.57 billion and Quen VL Chat 7 billion. On visual generation benchmarks, MS Coco 30K and Gen Eval, Janus achieved a FID score of 8.53. Now, you may think that sounds low. That is not low. Okay, people, look at what's your FID score? Your FID score ain't nowhere near 8. You couldn't get a 2. Okay? Ridiculous. And an accuracy of 61%, surpassing text-to-image generation models such as DALL-E 2 and Stable Diffusion XL. I mean, it's better than DALL-E 2. That's pretty good. We believe that the strong performance coupled with the high flexibility and extensibility of Janus presents it as a strong candidate for the next generation unified multimodal models. Lovely. This is a concept they put out there that is open, that other people could build on top of. We could see this concept of splitting out the encoding between generation and understanding to happen across the board. And maybe everything will get smarter. Okay, related work. Visual generation. Visual generation is a rapidly evolving field that combines concepts from natural language processing with advancements in transformer architectures. Autoregressive models, influenced by the success in language processing, leverage transformers to predict sequences of discrete visual tokens, codebook IDs. These models tokenize visual data and employ a prediction approach similar to GPT-style techniques. Additionally, mask prediction models draw upon BERT-style masking methods, predicting mass sections of visual inputs to improve synthesis efficiency. You take an image, you cover a part of it, you say what would go right there. Then you take the image again, you cover a different part, you say what would go right there. Eventually, you get a model that's kind of smart at filling in the slots, and you could just give it nothing, and it can fill in the whole thing. Concurrently, continuous diffusion models have showcased impressive capabilities in visual generation, complementing discrete methods by approaching generation through probabilistic lens. Lovely. Multimodal understanding. Multimodal large language models, MLLMs, which is different than MLMs, be very careful, integrate both text and images by leveraging pre-trained LLMs. MLLMs demonstrate a robust ability to understand and process multimodal information. Recent advancements have explored extending MLLMs with pre-trained diffusion models to facilitate image generation. These methods fall under the category of tool utilization, where diffusion models are used to generate images based on the conditions output by the MLLM. While the MLLM itself does not have the ability to directly perform visual generation, moreover, the generative ability of the entire system is often constrained by the external diffusion model, marking its performance inferior to directly using the diffusion model of its own. Okay, the fact that it's not under one umbrella means that since it's not using its own internal logic, it could get worse performance because it's talking to some other model. We want it to be unified with one autoregressive transformer, I guess. I don't know if I understand that properly. If you do, correct me, help me. Unified multimodal understanding and generation are considered powerful for facilitating seamless reasoning and generation across different modalities. Traditional approaches in these models use a single visual representation for both understanding and generation. However, we already know that it's not going to be the best. Chameleon adopts the VQ tokenizer to encode images for both multimodal understanding and generation. But why would you just use the VQ tokenizer to encode images for understanding and generation? We know that those are fundamentally different problems and they need different types of data. So this practice leads to suboptimal outcomes. The vision encoder might face a trade-off between the demands of understanding and generation. In contrast, Janus can explicitly decouple this visual representation for understanding and generation. So the architecture. The architecture is shown here in figure 2. Look at this here. We've got understanding, we've got generation. We see the autoregressive transformer right in the middle. We see here we've got image, we've got language instruct. We've got language instruct, we've got image. This is a text tokenizer, this is a gen encoder here. This is us trying to create an image, this is us trying to understand an image. Okay? For pure text understanding, multimodal understanding, and visual generation, we apply independent encoding methods to convert the raw inputs into features, which are then processed by a unified autoregressive transformer. I know, I've read that previously. Specifically for text understanding, we use the built-in tokenizer of the LLM to convert the text into discrete IDs and obtain the feature representations corresponding to each ID. For multimodal understanding, we use SIGLIP encoder to extract high-dimensional semantic features from images. These features are flattened into from a 2D grid into a 1D sequence, and an understanding adapter is then used to map these image features into the input space of the LLM. For visual generation task, we use the VQ tokenizer, just like what Chameleon was using, to convert images into discrete IDs. After the ID sequence is flattened into 1D, we use a generation adapter to map the codebook embeddings corresponding to each ID into the input space of the LLM. I totally understand that. We then concatenate these feature sequences to form a multimodal feature sequence, which is subsequently fed into the LLM for processing. If I'm trying to understand this, this is for visual generation. We're trying to generate images here, so we're trying to we want a transformer architecture where it's telling us, hey, here's the next token in line, but how the next token in line needs to actually be related to the image. How could we get it to relate to the image? I don't know. Bunch of fancy stuff here. This built-in prediction head of the LLM is utilized for text prediction in both pure text understanding and multimodal understanding tasks, while a randomly initialized prediction head is used for image prediction in the visual generation task. So, if we're saying, hey, here's some text, give us the next token, that's easy. However, we need to generate an image. There is no starting image. So what we have to do is there is a randomly initialized prediction head that is used to generate the image. The entire model adheres to an autoregressive framework without the need for specifically designed attention masks. Lovely. Okay. Now, the training of Janus is divided into 3 stages. Stage number 1, training adapters in the image head. The main goal of this stage is to create a conceptual connection between visual and linguistic elements within the embedding space, enabling the LLM to understand the entity shown in the images and have preliminary visual generation ability. We keep the visual encoders and the LLM frozen during the stage, allowing only the trainable parameters within the understanding adapter, generation adapter, and image head to be updated. Okay, that's obviously the first stage. That's what I would have done too. Now, the second stage, it's unified pre-training. In this stage, we perform unified pre-training with multimodal corpus to enable Janus to learn both multimodal understanding and generation. We're testing both now. We're training on both. We unfreeze the LLM and utilize all types of training data: pure text data, multimodal understanding data, visual generation data. Inspired by Pixar, we begin by conducting simple visual generation training using ImageNet 1K to help the model grasp basic pixel dependencies. Subsequently, we enhance the model's open domain visual generation capability with general text to image. Finally, the third stage is supervised fine-tuning. During this stage, we fine-tune the pre-trained model with instruction tuning data to enhance its instruction following and dialogue capabilities. We fine-tune all parameters except the generation encoder. We focus on supervising the answers while masking system and user prompts. To ensure Janus's proficiency in both multimodal understanding and generation, we don't fine-tune separate models for specific tasks. Instead, we use a blend of pure dialogue data, multimodal understanding data, and visual generation data, ensuring versatility across various scenarios. And then we get into the fun stuff. Okay, here's the actual training objective. Here's the math behind stuff. Here's where things are going. We get into the real details here. Okay, I checked this out before. Boom, look, a lot of math here. Look at all these. There's numbers on numbers. Okay, there's parameters on parameters. There's Janus and chameleons. There's animals and lavas and emus. But okay, cool. In general, yeah, here we're just getting down to a bunch of nice little fun math details that we don't need to get too deep into. It is the ability to actually know what is happening in memes. Very, very good. Let's read the conclusion. In this paper, we introduced Janus, a simple, unified, extensible multimodal understanding and generation model. The core idea is to decouple visual encoding for multimodal understanding and generation. I think that idea could spread to other models. I think people are going to say, hey, this seems like it's working. We can even extend it to different types of mediums in the future, and they're showing some pretty good results. I mean, it's China. We want to keep up with them, so we should just copy what they're doing. Extensive experiments have demonstrated the effectiveness and leading performances of Janus. It's also worth noting Janus is flexible and easy to extend. In addition to having significant potential for improvement in both multimodal understanding and generation, it's also extendable to include more input modalities. The above advantages suggest that Janus may serve as the inspiration for the development of the next generation of multimodal general purpose models. Lovely. Awesome. Seems cool. I did do a little experimenting with Janus Pro, and I was asking it, trying to actually have it identify the LLM dragon, and you know what? It was not working. It could not successfully know that, hey, it's actually thought. Let's see if I can do this here. I've got a bunch of goofy. This is I'm just going through my, there you go. Okay, so watch. We got a little, that's the LLVM dragon. What is this, and what is it from? Let's see how good this thing is, okay? This is the Janus Pro, waiting for the GPU to... Okay, what's going on? We're at peak hours right now? Come on now. Come on, give it to me. Give it to me. This image depicts a stylized dragon. Okay. It may be from... No. What game is it from? What is this from? Okay, don't tell me it could be from a game. Tell me what game it's from. It's an image of a dragon. Where did... I know it's not doing it here. It can't know this. I know it can't even know this. I was just joking. I got it to say on the last video I recorded, which you can go to the end of it, it said it was from like Digimon or from Yu-Gi-Oh! Or something. It actually said from Yu-Gi-Oh! Which was like hilarious. It just said Yu-Gi-Oh! So I wanted to see if that would happen again. It did not happen again. But pretty cool. Maybe we'll come back and read the pro paper later. Hopefully we actually have sound this time. Seems like a useful pathway forward. We could see people build off of the concepts in this paper. I'm not using Janus for image generation right now. I have to see, is it actually, is it going to pull into my workflow like Deepseek so quickly was? I don't know. But again, they're opening stuff for the public. They're figuring out cool new techniques. Deepseek, the company, seems to pretty much rule. I do a video every day. Yesterday, I uploaded this video without any sound. That's why I had to redo it again today a little bit earlier. So I will be back again today for another video. because those are the rules. Okay, every day a new video about something happening in AI, the future. Sometimes it ends up being in crypto because that space is mixed up too. Sometimes we're going to be reading tweets, sometimes we're reading papers, sometimes we're testing stuff out. So if you want me to look at anything, just say in the comments. Sorry about yesterday's video. I don't even know if I'm going to delete it. I'm just going to say it's silent and you can watch me talk in silence. So see you guys tonight for more.